So in this video we go over section 3.2, the graph of a function. So in this section we cover how to identify a function and how to obtain information from or about the graph of a function. So how to identify a function. So in order to determine whether a graph describes a function, we use the vertical line test. So in essence, drawing a vertical line on a graph, if that vertical line intersects the graph at most one point, well, then that graph will be a function. Otherwise, if the vertical line intersects the graph at more than once, then the graph will not be a function. Okay, so let's look at some examples here. Well, in this case, I'm going to draw a vertical line, and in this case we can see it only crosses once. Actually, anywhere you draw a vertical line, it will intersect only once. So yes, this is a function. For the second graph right here, if you trace a vertical line, well, it crosses only once, and likewise, just like the previous example, it's only going to cross only once. So yes, it's a function. Yes, it's a function. In this case, if you look at this, well, drawing a vertical line is going to cross more than once, so this is not a function. No, not a function. And same for this last example. It's not going to be a function, because in these two cases the vertical line test intersects the given graph at more than one point. Alright, obtaining information from or about the graph of a function. Well, let me move to the third page in this case. So we're given the graph of a function right here. So from this graph we're going to answer all these questions. So let's find f of 0. So f of 0, that means what is the y value when x equals 0. So f of 0 equals 0. It's actually the origin, and the corresponding point is right here. F of negative 2, in other words, what is the y value when x equals negative 2? So I'm going to go to negative 2 and look for the corresponding value, which is 1. F of 6. F of 6 is asking what is the y value when x equals 6. In this case, 0. Right? Now the question is f of 3 positive or negative? Alright, let's look at f of 3. Well, f of 3 is somewhere here, and in this case it's below the x-axis, so it's negative. For which values of x is f of x equals 0? So in this case we are going to look at these three values. In this case, x equals 0, x equals 4, and x equals 6. So those are the three values for which f of x equals 0. Now, for what values of x is f of x less than 0? Okay, let's see, what does that mean? F less than 0 means interval or intervals in which f of x is negative, that is below the x-axis. So I'm going to go up to the graph right here, and I'm going to draw a horizontal line exactly on the x-axis. Everything below is negative, everything above is positive. So in this case, I'm looking for the positive part, which go from 0 to 4. So in this case, this is not an ordered pair, but rather an interval. Okay? So, what is the domain and the range of f of x? Okay, so observing the graph, again, recall that in order to find the domain of a function from the graph, look at the graph from left to right for the domain. So for the domain, we're going to look at the smallest value of x, which in this case is -4, and then the largest value of x, which is 6. And in this case, notice we have full bubbles, we have solid points. So the domain is going to be from -4 to +6. Now, what about the range? For the range, we are going to look at the graph from bottom to top. We are going to look at the smallest value of y and the largest value of y, which in this case, it's going to be -2 to 3. Okay. What are the intercepts? Well, keep in mind that we look for X-intercepts, and also Y-intercepts. So again, recall that the X-intercepts are all the points in which the graph crosses or touches the x-axis. So in this case, the origin 0, 0, this point 4, 0, and this point 6, 0. On the other hand, the y-intercepts is a point in the graph. It's a point in which the graph crosses or touches the y-axis. So in this case, the origin 0, 0. The question is, how often does the line y equal to -1 intersect the graph? Okay, horizontal line y equals to -1. Notice this axis is divided into multiples of 2, so most likely -1 is over here. So I'm going to draw horizontal line at -1, and we can notice that this crosses twice. So the answer to this is 2 times or twice. How often does the line x equals 1 intersect the graph? Okay, vertical line x equals 1, and in this case it also crosses only once. In this case only crosses one, not also, just only once. For what values of x does f of x equals to 3? So in other words, they're asking us for the values of x for which the y value equals 3. In this case, for x equals, so where do we get y equals 3? It looks like we only get 1, that is 5. Now for what value or values of x do we get y equals -2? If we look at the graph, we get y equals -2 only when x equals +2. Alright, let's go back to the first page again. So in this case, we are given a function. We are going to obtain information but from an explicit function. So we're given the function f of x equals to 2x over x minus 2. The question is the point 1/2 comma -2/3 on the graph of f of x? Well, in order to determine that, keep in mind that this is x and this is y. So what are we going to do? We're going to plug in 1/2 wherever we see the letter x, and y which is really f of x, we plug it on the left side. Okay, so -2/3 equals 2 times 1/2, which is x, and 1/2 minus 2, which in this case is the denominator part. So let's simplify this and hopefully we get an equality here. That's how we're going to know that the given point is on the graph of the given function. So -2/3 equals, well, in this case, 2 times 1/2, the 2's cancel, we get a 1 in the numerator, and 1/2 minus 2, that's going to give us -3/2. Okay, so from here, I'm going to have -2/3 still on the left hand side, but in this case I have 1 over -3/2, which is 1 over a fraction, and then so dividing by a fraction is the same as multiplying by the reciprocal. So 1 times -2/3, which is -2/3. So in this case the answer is yes. The point is on the graph of f of x. Alright. The question for part B, if x equals 4, what is, actually there's a little typo, what is f of x? And then what is the point on the graph of f? So we're going to start with the function f of x equals 2x over x minus 2. So in this case they're asking us to essentially plug in the number 4 wherever we see the letter x, which in this case it's going to be 2 times 4, which is 8, divided by 4 minus 2, which is 2, and then divide 8 over 2, which is going to be 4. Now the question is, what point is on the graph of f of x? So in this case the point is going to be that in which x equals 4 and y equals also 4. If f of x equals 1, what is x? So now let us see in comparison with part B. In this case, it's kind of a backwards question. So in this case, they're not asking us to plug in x equals 1. So they're asking us to set f of x equals 1. That whole side is 1. Divided by x minus 2. Okay, so 2x over x minus 2. So in this case we need to solve this equation. What I'm going to do here is to cross multiply. So 1 times x minus 2, that's going to give us x minus 2 on the left hand side of the equation. And 1 times 2x, it's going to be 2x. So I'm going to subtract 2x to both sides. That's going to give us 0, negative 2, and x minus 2x, that's a negative x. Add 2 to both sides. Negative x equals 2, and finally divide both sides by negative 1 to get x equals negative 1. Now, what point or points are on the graph of f? In this case, the point for which x equals negative 1 and y or f of x equals 1. What is the domain of f of x? Well, this is something we already did in the previous section. Let's write the function again and observe that this function contains variables in the denominator. Well, it's actually 2, not a 4. So in this case, the restriction to this type of functions, rational functions, is that the denominator cannot be 0. So x minus 4 cannot be 0. So x cannot be positive 4, because if we plug in 4, look what's going to happen. We're going to get a 0 in the denominator. So the domain x such that x cannot be negative 4. Actually positive 4, not negative 4. Cannot be 4. Using interval notation, you might want to use the graph as we did in the previous section. So put an open bubble for that 4 that cannot be taken by the function. Right? So it's basically all these real numbers except negative 4. Using interval notation, negative infinity to 4, union 4 to infinity. And the last of this, list the intercepts. Okay, so the X-intercept recall that to get the X-intercept, we let y equals to 0. Again, keep in mind that y is also f of x. So set f of x equals to 0. So 0 equals 2x over x minus 4. Solving this equation for x, well, this is the same as saying over 1 and cross multiply. We're going to get 1 times 2x, which is 2x, and x minus 4 times 0, which is going to be 0. And dividing both sides by 2, we get x equals to 0. So that's the value for which the intercept is x equals 0. So the X-intercept using another pair, 0, 0. In other words, the origin. The Y-intercept on the other hand, for that, let x equals to 0 and simplify. In other words, let's do f of 0. Wherever we see the x, we replace with 0. And I don't know why I keep writing a 4. This is supposed to be a 2. Hold on, 2. And this was supposed to be, so I made a mistake here. This was supposed to be a 2, and another 2 here. Okay, so plug in 0, 0, 0. Wherever we see the x, we plug in 0 and simplify. 2 times 0 equals 0 divided by -2, which in this case is going to give us 0. So again, the y-intercept is also the origin. Okay. Alright, so this is the end of this section. I'll see you on the next video.